Okay, hi everyone. This is going to be a quick video just to show you all how to do the actual size analysis of the nanowires that you're going to be imaging in the cleanroom. And what we're going to be using is a program called imageJ. I'm sure most of you have heard of it, but it's free and it's a pretty powerful tool for kind of extrapolating crucial size dimensions of nanotechnologies like these nanoparticles or the nanowires that we're working on. But it's freeware. I think it's also available on the software farm at NTNU, but if not, you could just type in Fiji imageJ. I prefer Fiji. It's literally just imageJ with all these pre-installed packages that are very helpful. And we're not going to go too much into these packages. They're a bit, I would say, slightly more advanced approaches to image analysis. But for us, it's you guys have to do the manual work, unfortunately. But go ahead and grab it for whatever platform you work on. I already have it pre-installed, but just grab it, download it, install it, and then just open it up. And once you open it up, you should have a little bar like this. And from this, you can basically open up images like this. So this is just a zinc oxide nanoparticle film, and the resolution's okay. We can grab definitely meaningful sizes from this. So go ahead and just open the image. And so once you do that, it'll pop open. Right. Okay, so we have our image loaded. We can start grabbing data from here. But the first thing we need to do, and since if your scale bar is not unique, or if it is unique every single time, I'm sorry, if it's unique every single time, you're going to have to set the scale every time you open an image. Otherwise, you're going to have crappy measurements here. And so how we do that is we're going to take a measurement by clicking that line, and as close as we can to the scale bar here, we're going to measure. Press Control M to actually make the measurement, and a box should pop up, and it's telling you that that's the length in pixels. So we know that this is 500 nanometers, so we're going to set the scale by going to Analyze, Set Scale. You should have a window pop up here. So the distance in pixels is 1932. We know that that's 500 nanometers, so we can set that. Pixel aspect ratio should be okay, and then we set the unit of length, which is nanometers. So it's about 3.864 pixels per nanometer, and our scale is good. So every time you make a measurement now, you're going to be taking it at the correct scale. We could just clear that. And so the next thing you have to do is go to Tools and ROI Manager. So this little window should pop up, and it's going to be basically a data bank of every single unique measurement you make. And so the shortcut here is going to be T. So we can zoom in on our image, make a measurement, press T, and it's added to this bank. And so we can keep going. We add a second image, so now the other one disappears. So what we can do is press Show All. And so it keeps track of every single unique measurement you make, and we keep going, keep going, keep going. Of course, this is a very primitive way to do this, but it's a good introduction to the actual grabbing of meaningful statistics of these sizes. Okay, so after we've done enough, or what we feel is enough, we can come back here and basically select all and go to measure. And so what this produces is a database of all the measurements you've made. And so far we've taken 7. All this stuff is not important to us. What we want is the length, because this is giving us the diameter of the nanoparticles. Of course, it depends on how you take these measurements. If you take it this way or this way, it's going to be different every single time, but it's up to you how you will do this, and how it should be important to discuss maybe or briefly mention how the actual measurement taking affects the statistics. But basically from this we can take this and go into Excel, and that's when you'll do your histogram production, etc., etc. So that's for nanoparticles. So let's try something for nanowires. Let's open up something like this. So this is a previous one of my images for an experiment that you all have performed. So we're just going to clear out all our measurements here. Oops. So if you make a mistake, you just press Control Z. That's also true if you take a measurement that you're not happy with. Like say you did that and you added it, you have to individually come back and clear it out here. Okay, so once again, let's set the scale. So let's see the scale bar is quite different this time. So we have this, Control M, and our length is 566 pixels. And so to make sure we're pretty consistent, you can, if you would like to, do this multiple times on the scale bar to make sure that we're in the same ballpark. Control M. And so that was 566.01 pixels. So we're pretty close. We can take that, go to Analyze, set scale. It's our latest measurement is already put in here. So we know the distance. It's about 1 micron, 1,000 nanometers. Okay. If, for example, you have images that have the same scale bar every single time, you could set it to global and you wouldn't have to do this, but it might be different for you at different magnifications on the SEM. So let's clear these out. Okay, so now with taking measurements for nanowires, there's a lot of subjectivity that goes into this, and the results might vary per group. So it depends on you. Just pick a rule set when you label these things and try to be as consistent as possible. So for your images, the ones that I've already seen, there's a lot of fibrous material or some kind of polymeric residue, and we might have to clean them off a bit before we do the reimaging. But in this case, this is the zinc oxide nanoparticle film. This is a cross section. This is the wafer, and what we're going to do is just basically take a measurement like this, press T, add it to our database down there. Take another one, and so you want to go to the same point, or roughly the same point. That one might be a bit too far. The particle film here starts here, and we might be going back to it. But for the ones that are obfuscated or occluded in the back, it's never going to be 100% degree of confidence where you're going. But typically, it's going to be in this ballpark. Okay, so we have some 5 measurements. Let's add them to the database. Again, we have our lengths, about 1 micron, 700 nanometers. Take these and then add it to your Excel spreadsheet or whatever spreadsheet you're using, Python, blah, blah, blah. And from there, you can produce your histograms. So that's just for length. We want to collect some data about the diameter too. So you'd probably want to do this again. So let's just clear this out. And again, come back here. And then again, also it's going to vary based on person doing this. But as you can see with this one, this is very early growth. It's about 1 hour only. So perhaps the diameter is not uniform across as we stop mid-growth here. It's something you could talk about in your reports, but pick a point along the nanowires and stick to it across the whole measurement. So let's just say somewhere halfway, right? Boom, add it. Let's go here, add it. And so on and so forth. Again, you have all these measurements, add them to your database, and so you have about 70 nanometers across, 30 nanometers across. And make sure to gather these measurements, put them in your spreadsheet, blah, 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 generate your histograms. So that's about it. It's pretty simple. Just follow the steps. Let's see one more from one of the preliminary images that was taken by Amelie, I think. Let's go. So these are very strange immediately, but it's a good entry point. So like I said before, there's some kind of fibrous or some kind of polymeric or some kind of plate-like structure here. And it's clearly not attached to the nanoparticle film, but there's still nanowire growth off these things. Either way, if you have some weird image like this, you could still collect data from these things. So again, let's just make sure our scale is appropriate. Let's go here. Okay, add the measurement. There it is. Analyze, set scale. Distance in pixels is 480. We know this distance is 1 micron or 1,000 nanometers. Okay, our scale is good. Clear that, and we're good to go. We can measure. So let's take something like this. Add it. Add it. And again, remember, If you want to see all the measurements you've taken, just click the show all. This is just to show everything. So we have 3. We can come back here. Let's say I screw up too long, but I've added it. You could just go here and delete the single one. Okay, again, measure, and we generate our lengths here. And you want to do that for diameters as well. And from this, you can take, like I said, take this, generate your histograms, and let's see some size distributions. For now, it's just a general tutorial. When we gather more images, hopefully we have enough to generate some meaningful statistics. Let's see, and let's see if we can see some differences in the experiments. But this is a general procedure. If you have questions, let me know, and I'll be able to answer them hopefully. But yeah, that's it for now. Good luck.